Ladies and gentlemen, please welcome Habib Heydarian.
Almost. Good afternoon, everyone. My name is Habib Heydarian, and I'm a program manager on the .NET team. Let's start with some big announcement. What you're seeing on your screens in purple is our new .NET logo. It's very modern. It's very purple. And it's very flat, as in it follows the flat design UI guidelines. Truth be told, I actually don't know what the third thing means, but the folks who designed this logo tell me that flat is the new thing in. So with that, let's get started. So today's talk is about what is new in .NET development. Whenever I get asked what is new in .NET, the first question that I'll ask is, well, which part of .NET are you referring to? And I want to use this slide as the background for today's presentation. If I were to take a very, very simplified view of what .NET is, it's a core runtime, it's a set of rich libraries, a set of languages, and then the tools that all make up .NET. And in fact, since .NET 1.0, that's been our definition of .NET. So with that context in mind, what I'd like to do today is I'd like to give you an overall view of all the work that we've done across each one of those parts, except the languages. I'm going to let the language experts cover that hopefully in a future discussion. But what I really want to emphasize here is if you looked at the keynote this morning, where Googs and Shu showed off a lot of the work that our partners, our customers are doing in WPF, as well as enriching those WPF applications with store applications, I'd like to talk a little bit about what's going on in those areas. Okay. If you remember, we released .NET 4.5 about 8 to 9 months ago. I have to tell you, .NET 4.5 was a huge release from every single aspect. We made improvements in the client and devices area, web and cloud, fundamentals, GC, and libraries. And I'm going to highlight a couple of things. The async work is transformational. It is now being used across many of our libraries and across many of our software stacks. So I think that was a tremendous new capability in 4.5. And not to also forget about the store support that we did in 4.5. And with that, I asked my guys, and they tell me there are over 100+ million installations of .NET 4.5 today. And that goes without saying that we have not even released .NET 4.5 on Windows Update yet, but that's for another topic. So, if I were to describe what .NET 4.5.1 provides, I would say that we focused on 3 fundamental pillars: developer productivity, application performance, and this new continuous innovation that I'm going to describe some more at the end of the presentation. But let's get started with developer productivity. Okay. When I was many, many years younger, back in 2005, we introduced a tiny little feature called Edit Continuum, which is the ability to debug and change your code during your debug session. But there was something missing. If you look across Channel 9, Stack Overflow, User Voice, every one of these avenues, everyone is saying, where is 64-bit support? And so I want to apologize by saying sorry for keeping you waiting for 8 years. Edit Continuum for 64-bit is finally here. With around 2,600 votes, it is the number 9 on the all-time requested features on user voice. So we are very happy with that. One thing I want to mention is it works exactly the same way as 32-bit Edit Continuum. And we support clients such as WPF, Windows Forms, store applications, and ASP.NET web apps. And I'm going to show you a brief demo of what the experience looks like for web applications in the IDE. And I just want to set the context here. I have 2 laptops that I'm using right here. One is a Windows 8 laptop. The other one is a Windows 8.1 laptop. And that is because I want to show the differences in capabilities between Windows 8 and Windows 8.1. So if we could please have the second laptop on the screen. Wonderful, thank you. All right, so this is the Hello World application. And let me do a launch without debugging. So this is vanilla app, and the one thing that I want to show you right here is I'm going to bring up Taskman, and the thing that you notice is it is a 32-bit version of IIS Express. So what we want to do is we want to use the 64-bit version of IIS Express to showcase Edit Continuum. The first thing that after this presentation, when you all run out and want to try out this feature, please make sure that that Edit Continuum is enabled in your project properties for your web applications. And then in order to use the 64-bit version of IIS, you just go to Tools Options, and then enable the 64-bit version of IIS. With that, we should be all good to go. And I'm going to press F5. Hit the breakpoint. Hello, 64-bit ENC. And then I'm going to step. Step, and then press F5. And here we go. It is now in your browser. So that is 64-bit Edit Continuum for you. The experience is exactly the same as 32-bit. If you could, please go back to the slides. But there is more. I have to tell you, I believe .NET 4.5.1 is one of the most customer-focused releases that we've done so far. And the reason why I know that is we've been listening to you. We've been going to the various forums and then understanding what is actually going on. Another very highly requested feature is I want to be able to inspect the return value of my methods in the debugger. And so that's exactly what we've done. With .NET 4.5.1, you can now view the return value of your methods right inside the debugger. And so if we could please go back to the demo, I'm going to show you a very, very simple example. Let's hit F5. And the experience is, and I'm going to use the debug menu to step over the code. When I step, notice what is happening in the autos window. Step over again. And now we have the actual return value of calculate area in the autos window itself. The other thing that you can do is you can actually access the return value from the immediate window. So I can type in $return value and show me the return value. You can also use implicit variables to experiment with your code. What I mean by that is you can actually type in double area, which area does not exist in my code, assign it to return value. Oops, let me just. And that's been assigned now. And I can test for its value. Then I can continue stepping through my code and do things like, does surface area equals 4 times area? And the answer hopefully is true, right? So you can just see that by adding important features like the return value in the debugger, now you can take your debugging to the next level where you can experiment with your code without having to change your code in the IDE. Okay, if we can switch back. Great. Okay. One of our team members, Stephen Tobe, had written this great article called The Psychic Debugging of Async Code. And the reason why he mentioned that is async code is inherently parallel. And what happens is trying to find out the causality of why did this happen. It's actually quite difficult. So what we've done in .NET 4.5.1, and this is also supported for C++ and JavaScript as well, is the ability to debug your async code in a much, much more intuitive way. So what you see on the screen right there is in Visual Studio 2012, you can actually see the causal chain of async code. In VS 2013 preview, we've added features to both the task window as well as the call stack window to make it a much, much more intuitive experience. If we could please switch back to the IDE, I'd like to show you a very brief demo of what that experience looks like. So here I have an extremely simple, somewhat contrived example. And what I will do is I will press F5 and hit the breakpoint. Now, if you look at the call stack window now you can see 1 async calling, 2 async calling, 3 async, which you can't do today. The other thing that this allows us to do is you can use the task window to see exactly what state your tasks are in. So from here, you can clearly see that 3 async is where the current context is at. And you can see that, and you can double click on each one of these tasks. You can see that 1 async is right now scheduled to be run. What this allows us to do is clearly see what are your tasks doing at any point in time. So we hope that having this ability will make debugging your async code that much easier. Okay, if we can go back to the slides, please. Thank you. So as I mentioned, in .NET 4.5, we introduced the ability to write applications for the Windows Store. And so we've taken that a step further by looking at the various outstanding features or experiences that people are asking for, and also looking at how do we actually enable existing experiences for Windows Store applications. So what you see on the bottom, for example, is the 64-bit and continue, the managed return value inspection support, the async debugging enhancements are all supported for Windows Store applications as well. However, we also have added essentially features that fill gaps or improve the experience. And I'd like to cover a couple of those today. First of all, let's talk about being able to convert stream to random access stream. And why is that important? So I was looking around the web, and it turns out that a lot of people. This fine gentleman is saying, okay, I give up. I do not know how you convert a stream to an IRandom access stream. And the truth is that today you can't. And what you want this feature or functionality for is to be able to basically stream, let's say, an image from the web and then be able to display it in your Windows Store application. And the way you do that is via an extension method in Windows Runtime Stream Extensions that allows you to basically convert the stream. So what I'd like to show you right now is an example of that. So if we can please switch back to the IDE. Here is an extremely simple example of displaying the Bing wallpaper. And so if I tried to compile this in .NET 4.5, let's actually try and do that right now. The compiler is very unhappy, of course, saying I cannot convert stream to IRandom access stream. And so let's see if we can fix that right now. Now, you'll notice the actual method call isn't there yet. And the reason is, if you've looked at my Solution Explorer, this is still a Windows 8 application. So because this is a Windows 8.1 capability, I need to first retarget my project to Windows 8.1. And then once I've done that, I should be able to go back and simply call that method. So let's try it again. All right. Let's run the app and see what it actually does. And you'll be able to see that I've got mad UI skills here. So, but the point here is I can then easily now stream images to my Windows applications using the .NET APIs. Again, this is a huge existing pain point today that we've solved going forward. If I could please switch back to the slides. OK. The next thing that I want to talk about with respect to Windows Store application improvements in .NET is the ability to debug your Windows runtime components much easier from .NET. So today, let's say if you have a Windows runtime component written in C++, and that component happens to throw an exception. What actually happens is, unless there's a debugger attached, that exception information is lost. What that means is it makes it a lot harder to actually debug interrupt code, especially if you're using, let's say, a C++ Windows runtime component from C#. So what you'll actually see is a lot of the samples in the Windows SDK in Windows 8 have the message that says, exception caught, please attach a debugger. And the reason for that is there is valuable exception information that is not propagated through so that you can view it from your application in case you want to log or display that information to the user. So what the information that you see that is lost is the exception message. And in this case, what it's telling us is that the temperature was out of range. OK. Another important feature that we've added to .NET 4.5.1 is the ability to support nullable value types in WinRT structs. So if you're writing a Windows runtime component in .NET 4.5, and if you try to have a nullable value type in that struct, you'll actually get a compiler error today. With .NET 4.5.1, we've added the ability to support a nullable value type in a struct. So the example that you see right here, where I've got the title author struct, you can now compile this code in .NET 4.5.1 and be able to basically use this struct just like you do today from .NET. Okay. The last thing that I want to cover in the developer productivity before we move on to application performance is this feature that we're calling connection resiliency. What we know is as customers move their existing assets to the cloud, connectivity can become transient. You're no longer on the LAN, and therefore you're not guaranteed that you're going to have a great connection to your database. So in .NET 4.5.1, in conjunction with Azure Database, what you can do right now is take your existing application, and by just moving your database into the cloud, you'll get this great feature that will essentially, hopefully, do away with a lot of boilerplate code. To demo that, I'd like to switch over to laptop 1, which is this one right here. What I've got here is a beloved Windows Form application. And what I also have displayed is the TCP viewer, which allows me to see all the traffic that's going across the wire right now. So what I'm going to do is I'm going to launch the application without debugging it. And as I said, my design skills are pretty amazing, so I know you're all amazed. I'm going to type in the name John, and please look out for the connection being established in the TCP view. Okay, this is my connection right there. And let's say right now this was a mobile application and your user goes out of range and your connection drops. We're going to simulate that by right-clicking on my connection and doing a very bad thing, closing the connection. So what happens if I try now a query for Jane? Any guesses? This is a pretty bad user experience, right? Where just because my connection dropped, the application suddenly is no longer working properly. Now, this was on Visual Studio 2012 with .NET 4.5.1. Let me now switch over to my other laptop, which has VS 2013 Preview with .NET 4.5.1. Okay, exactly same code, no differences. Let me go and just dock this as I did with the other one so you can clearly see what is actually going on. All right, demos. And TCP view, launch TCP view, yes. Okay, exactly same setup. Let me go and start the debugger without debugging and do the exact same test. So I get John back. I'm going to go to TCP view, close the connection, and I'm going to now query for Jane. Notice what happens when I do that. My connection is restored by .NET 4.5.1 in conjunction with Azure. I think that's a pretty compelling experience where you no longer have to write a ton of boilerplate code to retry and retry and retry again. Okay, if I can switch to the slides, please. Okay, let's talk about application performance. Now, when it comes to application performance, it's a lot like fine-tuning the engine of your car. You might not notice it visually, but it's definitely there once you actually start driving the car. I am really excited to talk about this new capability in Windows Server 2012 R2 Preview that is called essentially ASP.NET Application Suspension. We are seeing some incredible results here. And let me describe to you what this is. So, if you're an enterprise today, such as Microsoft, we have at Microsoft hundreds and hundreds of line of business applications. Or if you're a hosting company that has thousands of applications. And I can tell you at Microsoft, our usage of those applications goes through cycles, meaning there are times of the year that we use the applications on it very frequently, other times we don't. And the idea behind the ASP.NET app suspension is the fact that with Windows Server 2012 R2 Preview and iOS 8.5, the actual ASP.NET worker process is suspended in what we call a ready-to-go state. What that means, and I really want to highlight the graph, the orange box that you see right there. In our initial results, where we've looked at websites like .NET Nuke, DasBlog, Simple Site, and so forth, we have seen a 7-time site density improvement. That is an incredible result when you think about the savings and the number of additional applications that you can host now. Now, let's talk about startup time. What we've seen is startup time in some instances has been reduced by 90%. Again, that is because we basically, once the application has been idle for a while, we put it in a ready-to-go state. We page it out to the disk, and then when the request then comes in, we essentially rehydrate the application and then serve the request. Now, if you're an enterprise today, so any of the major corporations or even and also smaller companies, I think this would essentially translate to hopefully lots of cost savings and also a much better experience for your users. Now, the feature is actually called idle worker process page out, and the way you enable it is to set the idle time action to suspended. And you can actually specify a time after which it will then page out, suspend, then page out the application to the disk, and then when the next request comes in, it will rehydrate it. And essentially, .NET 4.5 is the implementation that made ASP.NET work with in iOS 8.5 when it comes to this feature. So we think this is going to be a huge feature. We're going to have a lot more detail of exactly how we perform these tests and how you can also hopefully replicate the same results. Okay. I was seriously debating whether I should put this slide in this deck. Can I see a show of hands? Who here has heard of large object heap fragmentation? Okay, that's more than I anticipated. All right. Okay, so what we found is there are a certain few cases where essentially the large object heap gets fragmented. Now, if you look at .NET 4.5, by simply upgrading to it, we've done a lot of work to reduce that fragmentation. But I have to tell you, the .NET GC is one well-tuned machine. I would argue we have some of the world's best engineers squeezing the last bit of performance out of our GC. Personally, hopefully, you should never have to rely on using gc.collect. And the caution here is that, with great power comes great responsibility. And in this case, if you are like this fine gentleman or gentlewoman who goes by the name of Anonymous, they're really passionate about this feature, and we love that. In fact, let me read you what it says. It is an absolute disgrace that LOH compaction is not supported. Please make every effort to include it in this feature in the future version. And so, that's exactly what we've done. Just as a refresher, whenever you allocate objects that are greater than 85,000 bytes, I should say greater or equal to 85,000 bytes, these are treated specially. They're allocated on the large object heap. These are very expensive to compact, meaning it takes a long time for the actual collection to finish up. And then they're typically connected with Gen 2. So what we've done in .NET 4.5.1 is that we've introduced a static as part of GC settings called GC LOH compaction mode that will now allow you to compact the large object heap. Hopefully, that will make some of you in the audience very happy. If you have never heard of the LOH, that is perfectly fine as well. I am willing to leave it there. If I could please switch to the second laptop right here, I'm going to show you a brief demo of what this feature actually looks like in the IDE. Excellent, thank you. All right, so I have to tell you, this is a very contrived example, so I'm not going to go through details, and please do not replicate this code. It's not real world at all, but it just goes to make the point. So I'm going to run LOH demo.exe. So let's see what actually happened. We were able to perform 53,000 operations before we got an out-of-memory exception. And all up, the heap size grew to about, 1.8 gig, something like that. This is for a 32-bit process. Now I'm going to do the exact same thing, except I'm going to run it with the compact flag. So initial allocation was around 800. Then we were able to perform 20,000 operations. Heap size grew to now 1.7 gig. Now, the large object heap collection is happening. You clearly can see that your application has slowed down. And that's why I said with great power comes great responsibility. But the point that I'm trying to make here is that, we are no longer seeing an out-of-memory exception. We are now on 40,000 iterations and still going. The heap size around 1.83 gig. And I have to tell you, I can stand here for the next, 20 minutes and continue this application, have this application continue running. But you can clearly see now, at 60,000 iterations, we have passed the 53,000 iteration mark. And if you have a large object heap fragmentation problem. With this now, hopefully it will get solved. So what is the actual semantic of using LOH? And I'm going to now stop this. If I could please go back to the slides. Okay, so you can use the LOH compaction API in two ways. You can tell it collect right away, or by just setting the flag, you can then, whenever the next essentially collection happens, the large object heap will also be collected as part of the next collection. But I'm going to leave you with one final point before wrapping up on this topic. If you really believe you have a GC fragmentation issue, what I'll kind of refer to as the ginormous GC fragmentos syndrome, I actually encourage you to email Maoni. I really do. She is our resident GC ninja, and don't let this is actually her real profile picture at Microsoft. And don't let the cute kitty picture fool you. She's just incredible. She knows more about the GC than anyone else. So if you are having a GC problem, I would say the first thing that I would highly encourage you to do before unleashing this new weapon in all your hands is look at the architecture of your application, look at how you're using objects. Then, if you have a question, Maoni is more than happy, and that's why I put her email address up there. She will be able to answer any of your questions. Okay. You notice a lot of discussion that I'm having right now is around the belly, so to speak, of the beast. It isn't anything flashy or kind of visible, but one of the things on the .NET team, our job is to do the really, really hard work to make sure that all your apps run in a great, great way. So one of the key features that we've added with 4.5.1, and the beautiful thing about this is that you get all this for free, and that's how we like it. We do not, in an ideal world, every release of .NET would not require you to reset your world, right? Wouldn't it be wonderful if you just get .NET, your application's faster, it's more reliable, it's more secure? That's what I call an amazing upgrade, and that's what we're trying to strive for going forward. One of those is around multi-core JIT improvements. This is an improvement within the runtime part. If you remember, I talked about .NET is made of runtime, libraries, languages, and tools. So we added this new feature in 4.5 for client applications. And with 4.5.1, we are now also supporting ASP.NET websites. So what does that mean specifically for you? If you have an ASP.NET website today, by upgrading to .NET 4.5.1, what we're seeing right now is you get a 15% performance improvement on cold startup. I would argue, as an engineer, that's pretty awesome savings. You're not having to do any work and just getting, over 10% of performance improvements. I think it's a great deal. Now, on the warm side, which is actually the gray and yellow, we're seeing less of a difference with multi-core JIT for websites. But really, think about this scenario. Your ASP.NET application just hung or it crashed and you have to restart the application. And instead of having to wait many, many seconds, you are now reducing that number hopefully by 15, maybe 20%, so that your users will get a much, much better experience. So again, we're hoping this will just work without you having to do any work. Okay, let's talk about servicing. This is near and dear to many people's hearts. Patch Tuesday is in many folks' minds not the most memorable day, or the most memorable day for the wrong reasons. Servicing 1 billion plus PCs is a big deal. And .NET Framework is installed on 1 billion plus PCs. Why is it a big deal, and why do we take it so seriously? Let's do a very simple math calculation. Let's say that out of the 1 billion machines, when we updated .NET, we regressed just 1%. 1% regression out of those 1 billion. If I do my math right, that's around 10 million PCs that essentially either got hosed, applications don't work properly, and it's so critical for us to make sure that we do a fantastic job on servicing. And that's why we're taking upgrades so seriously. So what we've done for Windows 8.1, one of the canonical problems that we get many more reports on is, okay, Patch Tuesday just happened. My machines were magically upgraded to the latest patch, and then suddenly my application slowed down. What is going on? I didn't do anything. And the core problem was this. In order for us to improve the performance of .NET applications across the machine, we essentially will take your assemblies and then compile them or pre-compile them down to native code. This will significantly improve application startup time. Up until Windows 8.1, when we serviced .NET, we would essentially invalidate those native images. And what that would mean is you now have IL that needs to be jittered by every single application on your machine until we got our next opportunity to essentially pre-compile those core .NET assemblies to native code. With 8.1, we did a tremendous amount of work that, again, you'll have to do no work here, and that's how we like it. We like to just make the upgrades and make your applications beautiful and fast. So in 8.1, whenever we service .NET, and that includes security patches, that includes major bug release fixes and so forth, when you then launch your application after installing the latest and greatest bits, it will be just as consistent as previously when it comes to performance. What does that actually result to? So nowadays, chewing up CPU on devices is expensive. What I mean by that is battery life is precious. So rather than us sitting there for maybe up to 20, 30 minutes and simply pre-compile the binaries using Engine is now not only impacting your device experience, but also taking away from your precious battery life. So again, this is a fundamental performance problem that we fixed in .NET 4.5.1. Okay, let's now move on to the third pillar of our discussion. And this is what we're calling continuous innovation. I get a lot of questions around what's happening with .NET, where is .NET going? And the thing that I'd like to point out is the fact that the reason why people love .NET is because we have a set of core values. People love the fact that it's all very discoverable, all in one place, one-stop shopping. People love the quality and maturity of .NET. People love a single license and support policy, a centralized patching. And if you look at it, we have a broad set of customers. We have customers in the enterprise, the Fortune 500s, that are telling us, keep .NET stable. We love to be able to support our application for the next 10, 15 years. And please, stable, stable, stable. No innovations. On the other side, we have folks that are, just at the kind of forefront of change, right? There's all these new frameworks coming out, and so they wanted all new devices coming out. They want to be able to, the early adopters, be able to adopt the latest and greatest technology. And what they want is, what's happening with the latest library XYZ, and why am I not seeing API, ABC, and so forth. And so this is where we already have been going down the track, and ASP.NET is a great example here, right? For the last few years, they've done a tremendous job releasing these new innovations out of band, SignalR being a great example, and various other frameworks, so that you have these libraries. You don't have to upgrade your core runtime anymore. You can have these latest and greatest libraries and still remain highly compatible. So the new values that we are adding is to be able to release on a faster cadence that you can essentially opt into. And also, we want to have less friction when it comes to using new .NET features. We hear this a lot. The latest and greatest feature in library X comes out, and people really love the library, and they don't necessarily want to upgrade, or can't, in fact, upgrade the core runtime and the framework, but they want to be able to still consume that library. And this is one of the things that we want to continue doing. And I want to point out the fact that we've been doing this for a while now, but really formalize that process of how do I keep the core parts that I want stable, keep them as they are, but also be able to adopt the latest and greatest in new features. And that brings me to the discussion of NuGet releases. Can I see a show of hands, please? Who here knows NuGet is? Okay. Just briefly, NuGet is our essentially package management system in Visual Studio. It's fully integrated. And so for those of you who are aware, we released two components on NuGet, MEF, Microsoft Composition, and TPL Dataflow on NuGet in 4.5. I really want to stress the fact that these packages and new packages that are released by Microsoft are fully supported. And so we continue to keep the core stable, reliable, and fast. And you've seen several examples today of how we're doing that. But at the same time, we're going to keep the pace of innovation going, but being able to release capabilities and libraries in such a way that will keep up with your workload. So if you have a web workload that is perhaps evolving faster than your other workloads, you shouldn't have to be blocked until the latest and greatest whole thing is dropped on your lap, right? You should be able to opt in and choose and select the capabilities that you want. Again, I want to stress the fact that these are fully supported by Microsoft. So what I'd like to announce today is the official .NET Framework NuGet feed. For those of you who've seen the NuGet package management dialog, it's really hard today to understand what are the officially released .NET Framework packages that are coming out of Microsoft. So we've added, and you can see the area that I've highlighted, we've added the official channel, which is essentially one-stop shopping for all your Microsoft released .NET Framework packages. So you can now consume this feed in VS 2010, 12, and 13 preview. And also, it's on the web. And in fact, you're going to get the exact same experience. You can clearly see all of the stable packages. And you can see how many times they've been downloaded. These are all the stable packages that are being continuously updated. And the thing that I love about this is that you should see the turnaround times on the feedback on these, right? In the past, it would personally frustrate me. I would go on the forums, I'd go way back, I'd go on the news groups, and I hear folks say, I really want feature X. And it would take us 3 years to get to feature X. With this, and I would highly encourage you to go and look at this today, or whenever you get a chance. The turnaround time is incredible. We release feature X, or we get a request for a library. It's like, well, here it is. What do you think? Then we get continuous feedback, and we can release these on a much, much frequent basis. The thing I want to point out also is we now have this functionality through pre-release packages to get early feedback. Imagine that, getting your feedback on what .NET Framework should do going forward. That, to me, is a true innovation that we were never able to deliver on before. And as I said, it would really frustrate me that we could never meet that demand going forward. So that means now everyone in this room and everyone out in the internet now can participate in providing feedback and also help us shape what features and capabilities we want to support in .NET going forward. So what I'd like to do is, if I can please switch to my second laptop, show you a very quick overview of what that actually looks like. And it looks like I have to go here. Okay. So, as I briefly showed you in the dialogue, now I can look at all the .NET Framework packages that are being released and fully supported by Microsoft. And you notice we have, I only want the stable libraries, essentially. Or, if you actually want to try the latest and greatest, and when I say latest and greatest, this is something that we could have released yesterday. Now you can actually try it out, see whether you like it, see whether it fits your needs, and then provide us with feedback. We have this great feedback mechanism that you can now participate in. And then, at your choosing, you can then decide, whenever you're ready, to get the latest and greatest updates for a particular package, right? So it's no longer the case that, oh, wow, I found this bug in HTTP client. Oh, it's going to take Microsoft 3 years to fix and release that bug. We are now literally sitting at the other end. We have a team that will look at the feedback and have a conversation around, these are the highest priority bugs that we need to look at, and here's the feedback on the set of libraries that we are releasing. And the one last thing I want to point out about this feature is the fact that the feed is fully supported also in tools options. So you can clearly see this is now the official .NET Framework feed in NuGet, where you can get the latest and greatest .NET libraries. If I can switch back to the slides, please. Now, as I mentioned, this is already enabled in VS 2013 preview, but you don't have to wait. This is such a fundamental and an important benefit in my mind, right? Now you can use VS 2010, VS 2012, and get the same goodness as folks who are using VS 2013 preview by simply adding the feed in your tools options. Now you can get the latest libraries that support the various tools going forward. Okay, so with 5 minutes left, I want to summarize what we discussed today. As I said, .NET, in my opinion, is essentially an umbrella for many technologies and innovations across Microsoft. Whether if it's across the runtime, libraries, languages, and tools. What we've done in .NET 4.5.1 is, as I said, I believe this is one of the most customer-focused releases that we've had, and not to mention the fact that this has been in a release that we are providing in under 1 year, where we're focused on developer productivity, application performance, and continuous innovation. And one of the things that I really want to stress about .NET 4.5.1 is that we really want you to get almost all this stuff without having to do any work. I think that is a fundamental benefit that you're going to see of .NET going forward, where, you know what, performance just gets better. I don't have to change my code. So with that, we really would love to hear from you. As I said, we have a team of 20 or 21 program managers that are continuously looking at the .NET blog. We have an email that you can directly email us, MSDN forums, or if you prefer to use some of our partners, we have a .NET presence on Facebook, Twitter, as well as User Voice. We would love to hear your feedback. Okay, and last but not least, please fill out the evaluation form, regardless of whether you loved or hated this talk. And with that, I'd like to turn over to any questions in the last 3.5 minutes. Thank you.